welcome back. We are in section 4.8 and we're going to tackle example 2, and I don't know how much time this is going to take. It may take quite a bit of time, but you do need your graphing calculator. If you don't have it, you're not going to be able to do what I need you to do today. All right, so grab that graphing calculator and let's get it ready. And our lesson's going to focus on least squares line, or in other words, the line of best fit. On your algebra state test, you may see both words used. They may ask you to calculate the least squares line, or they may use the terminology find the line of best fit. That's fine, okay? Now the line of best fit, I defined it for you. Your book tells you it's a line that comes closest to all the points in the data set using a process called linear regression. Now when we get to the calculator portion, I'm going to show you where that pops up in the keying sequence. So you're going to see a symbol, a couple letters that say lin-reg, just like I wrote on your notes there. Lin-reg is just code for linear regression. I'm not going to get into the long and the short of what linear regression is. Just know it's the process that your calculator is going to use to calculate the line of best fit for you. Now example 2, we're going to find that least squares line, that line of best fit, and they've given us a series of data, and we're going to be doing that. On the next page is a list of written directions for you to put information into your calculator, and then on the very next page after that, we're going to answer some questions. Now the first thing I want to do is I'm going to switch over to camera mode. All right, there it is. And you see my book is underneath with all the data, and then there's my calculator right beside it. And I'm going to literally show you the keying sequence to getting all your data into the calculator, okay? So I figure this is probably going to be the most efficient way. You've got your written directions. You're watching me plug in these numbers into the calculator, so between the two, you should have no trouble getting this information in. Once you do it a couple of times, you know exactly what to do. All right, let's get started. First thing I want you to do is turn on your calculator and let's get that screen lit up. And as you can see, there's a button that's called the Stat button. Do you see me pointing to it? I hope you can see that. It's right by your group of arrows here, and there's your second button, there's the alpha button, and if you go right 2 places over from the alpha button, there's the Stat button. Press the Stat button, and you're going to see your screen pop up. It's going to say Edit Calc Test across the top. Well, we want to edit. When you want to input data, we're going to edit using that button, and then here's the screen that pops up. There's L1, L2, those are the 2 columns we're going to focus on. Now if there was data in the L1, there's a way you could clear it out. You could highlight L1 and hit clear enter, and it just will wipe out all the points in the L1 column. And if there were points under the L2 column, the same thing, just highlight L2, hit clear, enter, and all that data will disappear. So just make sure that your calculator has nothing under the L1 and nothing under the L2. Now let me show you how to plug in information on the L1. I think in your note packet as well as in your textbook, we're going to input the latitude. You see 2 columns of data. The left column, the first column on the left, is going to go under L1. And so we're going to focus and concentrate on entering those numbers in. So here's how it goes. You go 71.2, hit enter, and it pops in there. And then it moves down. 62.1, enter. 51.3, enter. 41.9, enter. 37.5, enter. 32.7, enter. 27.7, enter. 14.0, and 12.5. Put all those in. I would just take a quick second, double check, make sure those numbers are correct, that you didn't skip any digits, make sure your decimal's in the correct place, and make sure you have all the numbers that should be there. There should be 9 numbers. Just quickly count those up. Okay, right arrow over, and let's get the L2 information in. The right column is always going to go under L2. And in this case, the right column in our example is average temperature. So we need our negative button, so let's type in negative 12.7, enter. Then negative 10.1, enter. 10.4, enter. 10.3, enter. 13.8, enter. 22.8, and then, oops, see how I miswrote that? It showed up as 2.8 instead of 22.8. Just overwrite it, and it shows right back up. So if you make a mistake, just go back to that line and write over the top of it the correct information, okay? And then take a split second and just make sure that those numbers are correct. It is essential that you have the correct sign, that all the digits are there, and that your decimal is in the right place. And we have the same amount of numbers. We have 9 numbers under L1 and 9 numbers under L2. So just take a quick second and double check that. Okay, now what we're ready to do now, we use stat and edit to put the numbers in, to input the data. Now we want the calculator to tell us the equation for the line of best fit. So this is what you're going to do. You're going to hit stat again. And now we're done editing, so we're not going to edit again. All the information's in there. Arrow over and highlight calc. We're ready for it to calculate for us. And then arrow down and until you highlight number 4 on your calculator. Do you recognize the word that's there, lin reg? Do you remember what I told you that stood for? If you said linear regression, you're exactly correct. Good job. All right, so hit enter. If you have a TI-84 plus C Silver Edition, your screen's going to pop up this way. And what I need you to do is arrow down until the word calculate is highlighted and then hit enter. For everyone else, just hit enter again, and what should pop up is y equals ax plus b, and then they're going to give you the numbers that a represents and b represents. There's a couple of other numbers there. Just ignore the r squared and the r for right now. I will address those in the next example. If you don't see r squared and you don't see the r, I will show you at the beginning of the next example how to get those to show up in your calculator. So please don't panic. I will help you 100% of the way. Okay, do you see y equals ax plus b? Do you know what form that looks like? If you said slope-intercept form, you're exactly right. So the A is your slope. Why in the world they didn't use M and program M in there, I don't know. I wish they would stay consistent, and they don't. It's not your fault. Just remember that A in AX plus B is the slope, and B is your Y-intercept. Okay? So there's a little keying lesson. We're going to switch back over to Mimeo now because we need to answer some questions about that line of best fit. So letter A says find an equation for the line of best fit. Well, here's what we see in our calculator. And for A, what I want you to do is just round it to 2 decimal places. So we're going to make it negative 0.69, okay? 2 decimal places, that's all you need. And then B, we're going to make that 39.11. Awesome, that looks great. So let's just go ahead and write the equation, inserting negative 0.69 for the A and 39.11 for the B. And there's your equation. That looks great, okay? We need that equation because later on down the page, they're going to ask us to use the equation to estimate the approximate latitude of, or actually to predict the temperature of Vancouver, Canada. So we're going to get to that a little bit later. Let's look at B now. Interpret the meaning of the slope and the y-intercept. So here's the slope. We know that that's the number, but what does the number mean? And here's the y-intercept. Here's the number, but what does the number mean? And so what I want you to do is, we're not going to graph all these points, but I want you to see what the y-axis equals to and what the x-axis equals to. So if you remember from our columns, the left column is latitude, and latitude is going to be our x-axis, okay? So latitude is our x-axis, and our y-axis is going to be average temperature, okay? Now I gave you that visual because I want you to remember that for slope, and I'm just going to write slope this way, I'm just going to write it in fraction form like that. Reason being because of rise over run, okay? Boy, we just can't seem to get away from that. Things just keep resurfacing, don't they? Rise over run. Now our rise is going to be average temperature, okay? And our run, our x-axis, is the latitude, okay? So hopefully seeing that order, the way that they're ordered on your slope, perhaps will be a great way for you to remember this. Now, average temperature is in terms of degrees Celsius, so I don't know if that's going to play a part in that at all, but, and we'll just say latitude, we'll just say plain old degrees, okay? So here's the interpretation. You would say for every degree latitude, the temperature, this is where the sign is going to play a big part, it's negative, so the temperature decreases 69/100ths of a degree Celsius. So as we increase in latitude, for every degree we go up in latitude, the temperature is going to fall 69/100ths of a degree Celsius. So that's your interpretation for slope. That's how you would interpret it. On an algebra state test, or even on my test where it's multiple choice, you're going to have to read the choices and select which one makes the best sense in that case. There might be some that sound pretty good, but are they the best choice? So please be careful with that, okay? Now let's move on to the y-intercept. And remember, our y-intercept is going to be 0, 39.11. And 0 is our x-axis, and that's latitude. And then 39.11 is going to be temperature. So the interpretation of this is that at 0 degrees latitude, the average temperature is 39.11. That's how you interpret the y-intercept in this particular case. We practiced with that, so I'm hoping that that's not too bad for you, that you were able to figure that out. So I think probably the harder of the two was probably the slope. I think that was a little bit harder, but you may not think that. Okay, so we're done with letter B. I'm going to erase, and you guys, you don't erase. I just need a little bit of space down here. And now we're going to answer the final question, and this is what we know. The approximate latitude of Vancouver, Canada is 49.1 degrees north. Use your equation to predict Vancouver's average temperature. Okay, so we're looking for average temperature. So we're going to use that equation that our calculator figured out for us, and we're going to plug in our latitude. Remember, our latitude was the left column. That was our x. So this number is going to get plugged in to the calculator. So in your calculator, this is what you're going to do. And I'm just going to write it out for you. And then I want you to take your calculator. You should already have it. And let's calculate that together. So negative 0.69 times 49.1 plus 39.11. And that's going to give us an average temperature of approximately 5.231. And you can just leave it as 5.23 if you'd like. We'll just leave it as hundredths, okay? So there's our degrees right there, and that's the approximate average temperature. We're estimating, we're doing the line of best fit. It's not exact, so we're in the ballpark. It's going to be around that based on the trend, okay? So you've learned quite a bit. I've got another one for you to try. I want you to try the keying sequence. Remember, this is going to go in as L1. This is going to go in as L2. I want you to do the equation and then interpret, and then use your equation in letter C and find the cost of that 1,000-yard ball of yarn, okay? If you have any further questions, let's practice in class tomorrow, and I'm sure you're doing a great job. Bring your questions to class. Thanks.